the Sustainability Management Master's Program, you are answering one simple question. Do you care about your future generation? If you care about your kids, their grandkids, then you care about sustainability. And a sustainability manager is someone who has the tools to make people understand how they can contribute towards developing a sustainable world. We have both part-time and full-time students. Our curriculum is 30 hours. Instead of thesis, we have a research project course and a seminar course which provides them with the kind of research background they will need to be successful in their job. But at the same time, sustainability is not always everything about environment. It also relates to the business. They will take a sustainable business strategies course. They will take a project management course. Most of these courses are going to be taught by industry people, the people who are doing sustainability on a daily basis as a part of their job. Any organization that has a large number of employees and has a physical infrastructure, they will have to have a sustainability office. If you have the passion to develop and maintain a sustainable world, come to us and we will help you shape your passion into a career which will create an impact.
The Fall 2025 Sustainability Seminar Series. So we have put together an excellent slate of speakers this semester. Visit our website, the seminar series website, to look at the slate, or you look at the syllabus, which is uploaded in Canvas. So those of you who are taking the seminar for credit, you definitely have to see the syllabus that I uploaded on Canvas. It is self-explanatory, and if you have any questions, feel free to email me. We are not going to discuss the syllabus in class. Again, as I said, it's very simple, self-explanatory, but if you have questions, just shoot me an email. All our speakers have kindly agreed to stay behind the seminars until 6:20 p.m. to chat with you and use this opportunity to network with some of the best minds in sustainability, because those are the ones who we are bringing in here as speakers. And maybe some of them can become your industry mentors in your capstone projects. Okay, they are also looking for bright students to work with them. Okay, so after the end of the seminar, Khalid will open a breakout room where you can interact with the speakers. And to attend, you must be either a sustainability management student or enrolled in the seminar course. So today's seminar is sponsored by HDR, who are one of the joint sponsors of the Hugo New Corporation Sustainability Seminar Series. And our speaker, Joshua Gillespie, is the Environmental Sciences and Planning New York and New Jersey lead and contributor of HDR Sustainability Practice Group. He got his BS degree in Environmental Science and Forest Biology at SUNY Environmental Science and Forestry at Syracuse University. Josh has 26 years of experience conducting environmental assessment. Man, that's a long time.
Yes.
And for a diverse range of large-scale projects, including energy, power, highway, bridge, transit, rail, and facilities development. He is currently working under contract for the New York State Energy Research and Development Authority to support the state's offshore wind program. And today, he will talk about the challenges and benefits of that exciting program. So all yours, Josh.
Okay, thank you, Debs. Let's get started here. So as Debs mentioned, I work with the agency called NYSERDA that oversees the offshore wind program for New York State. And that has just evolved over the last 7-8 years. But I've been working with NYSERDA for the last 3 years. Quick agenda. Sorry, it's a little busy there, but couldn't find the right color. So we'll go over the case for offshore wind. We'll go over the offshore wind fundamentals, go through all the components of an offshore wind farm, challenges of offshore wind, the overall U.S. offshore wind program, followed by specifically New York State offshore wind program. And then what you might be most interested in is jobs and the economic benefits of offshore wind. And so yeah, throughout I'll be talking about benefits as well. But that's kind of an overview. So the case for offshore wind. Um, so if you look over to the right at the map that shows wind speeds across the coastal areas, we have a very attractive wind speeds for offshore wind. There's a huge reason that we have Norwegian and Danish developers here now building offshore wind, and they've been encouraging the U.S. for decades to do so, as they have for the last 30 years over in Europe. They've been very successful with it, and there's just a great alignment of 80% of our population that lives near the coast, but it's also near some of the best steady wind speeds in the globe. And so it's just a really nice alignment for this renewable energy resource. Of course, this is a brand new industry. It's a major job creator, short term during construction. This is for the next, 15 plus years. They're build out of these wind farms. But then there's long term jobs as well as the wind farms transition to operations. There's a nice synergy with the trade schools and universities and programs that can align with offshore wind. And but moreover, offshore wind gives you a nice diverse resilient electricity supply. It avoids harmful greenhouse gas emissions from fossil fuels, and just gives huge amounts of public health benefits from less carbon dioxide, NOx, SOx, inorganic particulates like fly ash and soot, and in reduced levels of respiratory disease, asthma, heart disease, cancer, neurological problems. All these things are real benefits that will come as we build out offshore wind. So a little overview on the offshore wind energy system. So if you look in the graphic to the right, there's the seasonal kind of differences in generation of wind energy. It's optimal more during the fall and winter, and end of fall, winter, and spring. And solar energy, as you'd expect, peaks more in the spring and summertime. But then there's all similarly a daily rotation of energy pushes as well. Solar, obviously, during the daytime, and wind kind of peaks during the day. So with that understanding, we need better energy storage, and this maximizes the available energy, so you can have a steady source of energy throughout the daytime and the evenings. As I mentioned before, we're going to retire the old polluting power generators, and those are peaker plants, all fossil fuel generation sources. There will be a nice alignment of the offshore wind strategic locations, delivering electricity to the state's existing transmission grid, right to where the majority of the population is. But one item we want to point out is it's very difficult to track renewable energy. Once that green energy is on the grid, it's virtually impossible to track those electrons across the grid. But all you can do is track the contribution to the grid. So here's a little overview of New York City summer electricity fuel sources. You know, we're still relying on fossil fuels for the majority, for 70% of our power. But it's really growing on the zero emissions side, as you can see, over 25% with zero emissions, and that includes nuclear, hydro, and wind. But then there's an additional 5% of other renewables and hydro pump storage sources as well. So the transition has started. So fundamentals of offshore wind. So to give you a sense of scale, these offshore turbines are giant. They, as you can see with the graphic there, they're over twice the size of the Statue of Liberty, starting to approach the size of the Eiffel Tower. Right now, we see offshore wind turbines peaking out around 850 feet, and they're going to continue to grow higher. The you know the cutting edge engineering on offshore wind turbines continues to increase the length of the turbine, the height of the tower. They're trying to maximize the amount of power output of these turbines. And we'll get into more of the sizes of those components. So here is the turbine components. At the center, at the very top, you've got the hub. That's where the blades all connect and houses the pitch system, which optimizes blade angle and the rotation speed. You have the blades themselves. This is what's capturing the wind energy and spins from mechanical energy. You have the nacelle right behind the hub. That's the engine that converts mechanical energy to electrical energy. Everything is resting on the tower. The tower supports the mass of that nacelle engine, hub, and the blades. Then we have the foundation. This is what secures the tower to the turbine of the turbine to the sea floor. And there's a variety of foundations available to do that. And then there is array cables. Those are cables connecting from the turbine back to the offshore substation. And then you can see that on the graphic there. And then the offshore substation collects and stabilizes the power generated by the turbines and prepares it for transmission back to shore. Here's the export cable and onshore connection elements. The export cable is buried deep enough to avoid disturbing ocean users and wildlife, and transmits power from the offshore substation back to the onshore substation. We have the cable landing, so that's the horizontal. It's installed by horizontal direction drilling, which is a common method, both for mostly on land, but it's really to avoid obstructions, sensitive environmental areas. It's a very effective tool installing through the land side of the cable. Onshore connection, this is where electricity is transferred to the existing transmission network finally. So here's kind of an overview of what that does look like. The wind turbines capturing the energy, transmitting it back to an offshore substation that's collecting all the turbines within the wind farm, and then it's transferred via export cable back to onshore and the grid via the transformer stations. And here's another graphic of an overview. This is kind of repeats the previous slide. So here's a sense of scale of the turbines. Currently most turbines are generating 15 megawatts. And one turn of the 15 megawatt turbine can energize a house for 1 to 2 days, just one spin. Every year, one turbine can produce enough electricity for over 9,500 homes. And that's the 15 megawatt turbine. They're working on an 18 megawatt turbine. We're supposed to see that in the next 5 years or so. There is a 21 megawatt turbine that's in the works too. So that's we're just expect to see this trend of really maximizing, capturing that wind power. There's some designs now that stack the turbines. You'll have two turbines on one stalk of a tower. So they're doing everything they can to maximize the capture of that energy. To the right, it's just a sense of scale from Jones Beach. Empire Wind 1 wind farm would be a little over 15 miles off the beach. And you can see with that yellow line, that's how small it would be compared to your thumb, a quarter of your thumbnail. So, and that's on a visible day. So most days you're just not even going to see it with, regular humidity and cloudy conditions. Turbine foundations. So this is the base of the offshore wind turbines. And what I should mention here is that all proposed offshore wind farms on the East Coast require these foundations. They're what's called fixed bottom wind farms, and so that means that they're secured to the sea floor, to the ocean bottom, with one of these foundations, monopiles, the jackets, and then there's they say there's 5 other types, but the more common version are the monopiles right now. But depending on the seafloor type, they'll adjust the type of foundation. So fixed bottom wind farms is really what you see right now, especially on the East Coast. And fixed bottom can work up to 60 meters of ocean depth. Once you get beyond 60 meters, foundations no longer become very economically viable or attractive. So we then go to floating ocean wind farms. And so those are proposed off the coast of Maine and also off the coast on the west coast where the ocean's far deeper. Though the floating wind farms are still anchored to the seafloor, but yes, the entire turbine is in a floating mechanism. Here's a quick look at the cables used. There's DC direct current and there's AC cables. HVAC cables are more economical than the DC cables, and they're usually used for the shorter distances. DC cables typically rely on the 32 kilovolt single core designs. They can transmit up to 1,200 megawatts per circuit. Globally, greater power ratings have been achieved for shorter lengths of HVAC and HVDC cable rated for 400 kV or higher. So for burying the cables, just to give you a sense, the U.S. Army Corps, and you have to achieve these federal permits as you build these wind farms. But the U.S. Army Corps currently recommends a burial depth up to 15 feet below the ocean floor. There's areas where they can have a minimum of 3 feet. And then typically 6 to 7 feet can be authorized too. But I think their preferred depth is deeper. just to avoid any interference on the seafloor bottom. Here's the inter-array cables. This is just a quick graphic to show that the alignment of the cable, from the nacelle, it descends down the center of the turbine and exits out the bottom before connecting down into a trench into the seafloor. The length of each of these inter-array cables can go up to 2 miles. This is within the wind farm itself. Export cables, this is the cable that brings you from the offshore substation back to land. And as you see here, they like to have at least 2 export cables per project for redundancy, and those lengths can extend up to 100 miles. So it's pretty impressive, the power that these cables can carry over that distance. Here is just demonstrating the space needs of the cables, the subsea cables, as as they leave the wind farm and head to the shoreline. Telecom cables, you can see there in the blue on the lower part of the screen. They usually are spaced with a 50-meter buffer. Offshore wind cables have a greater buffer, up to 60 meters between them, and that's to just control that electromagnetic radiation of the cables and not interfere with each cable. I should also point out, you see the green circles there, archaeology exclusion areas. Planning and environmental studies of these offshore wind farms gets really interesting. So, believe it or not, you have subsea archaeological exclusion areas, and these are places of pre-contact where Native Americans may have been present when the shoreline extended out there. So there's archaeology just extends so far back in history, so you never know when you're going to have those issues. But archaeologists become very important in the planning and EIS phases and permitting phases of these projects. This is a very common issue. Now we'll talk about some vessels. These are wind turbine installation vessels. As you see here, these are what they call heavy lift jackups, and primarily used to perform the turbine installations. You see everything's there on the deck of that vessel. What they do, they float it out to the site, and then they jack it up off the sea floor so it's stable, and then that allows a nice environment to operate a crane. And as you can see, all the elements of the wind farm are there: the towers, the blades, nacelles, the hub, and you can install from there. So, but one of the most time-consuming parts of the installation is installing the foundation and getting that precise and secure to the ocean floor. Once that's installed, it's kind of an erector set, and it does assemble fairly quickly once you're above the ocean level, above water. Foundation installation. There's also these heavy lift floaters. It's another set of vessels, primarily engaged in the foundation side of things. Both of these vessels are really from the oil industry. And that's why the Danish and Norwegian developers, were able to pioneer the offshore wind industry, as they realized they could use the same vessels and very similar equipment that they already had with the oil industry. So they used very similar techniques to experiment and come up with the best foundations to secure to the ocean floor. Pretty cool stuff. Then you have cable laying vessels. And so these have a double duty. They receive the cable from the manufacturing site at a port, and it's brought out. It's a long line, long cable, and it spools on the vessel, and they transport it out to the wind farm site and install the cable from there. But they're very high tech, precise vessels that need to be built, laying the cable per all of the engineering plans and specifications. And only the Europeans are building these cable laying vessels. We'll touch on that later, the reason why. So here's the vessels primarily used just during operations. Once that wind farm's constructed, to the left, you've got the service operation vessel, the SOV. So that's, kind of this mid-sized vessel that will handle the repairs to the wind farm. A blade breaks, the engine, it needs to be replaced, whatever the case may be. So it needs to be a decent sized vessel to handle those components and bring them out to the site. But it's also used just for routine maintenance and servicing the wind turbines. And so that's a 24-hour job. They're on call at all times. You got to make sure all the turbines are operating correctly. To the right is the crew transfer vessel. That's a CTV. I got to correct that slide. And that's just to bring out the crew back and forth, and that's more for visual inspections and routine maintenance. Kind of daily trips running out there, just monitoring and checking on the turbines. They could also get out there by helicopter. There's a landing pad on the offshore wind substation, and that's commonly used also. Helicopter fuel can be pretty expensive in the machine, but when they need to get out there in a hurry, that's the preferred mode. It's always helicopter. So here's a little section on the challenges of offshore wind. So this is the primary one. It's called the Jones Act. So this federal Jones Act requires transporting goods between the U.S. and ports. The vessels need to be built and flagged, have a U.S. flag, meaning they're from the U.S., and crewed from the U.S. To come ashore, bring components, and bring them back out to the wind farm site. So the challenge here is your European developers have all these vessels, have all the right equipment, have all the right cranes. They're not U.S. flagged vessels. So finally, in the last, it was about 4 years ago, they started building the very first wind installation vessel, and that's on the upper right of the slide, Charybdis. I'm gonna butcher the pronouncing of the name of that vessel, but that's the wind installation vessel. It was built down in Brownsville, Texas. It was just completed about a year ago, and it's about ready to be deployed for use at Dominion Energy's project off Virginia. It's the Coastal Virginia Offshore Wind project. And then later it'll be used for Ørsted's projects up by New York. There's an exception to the Jones Act, the cable laying vessels, because we know they're unique to the European fleet. Those do not need to be required to be Jones Act compliant. So the developers have come up with a workaround effort here where U.S. flag barges, and they call them feeder barges, will collect components and parts of the offshore wind turbines from the U.S. ports and maritime facilities and bring them out to the European vessel for installation. So we have this like shuttle system going on, with allowed American flagged vessels going back and forth. So it's not always the most efficient, but it complies with the rules. So here's an overview of the process that needs to be undertaken to finally construct an offshore wind farm. First is the federal process with BOEM. So you see the BOEM process, that's the Bureau of Energy Management. I'm sorry, the Bureau of Ocean Energy Management. So they oversee all the energy projects out in the ocean. They started with oil and gas, and now they're overseeing offshore wind. So you see the planning and analysis phase that takes quite a while, a good 2 years there. They identify potential areas with the scientists, look at those wind, most attractive wind areas in relation to a population center, try to align that. And then, but you also have to undergo environmental reviews. And so some of the big concerns out there, I'm sure you've heard in the news, is marine mammals. We have endangered species out there. There's migration patterns of whales and marine mammals, but also bats and birds out there. Very huge migration areas. So we try to align to miss those areas as best we can, and but still have an attractive location to deliver power, capture the right wind and deliver power to land. So it's quite a process. And then finally is the leasing process. And it's a very prescribed set of reviews to be able to issue the lease, and that goes out to bid, and then they award it to a developer who gives the best price, and then the developer has to undergo their process for approval. So they'll first do these site assessments to help inform their design. That can be up to 5 years. And then they enter a construction and operations phase, which can take up to 3 years. And that's where you do the EIS, you finalize your design, and you have to prepare what's called a COP, construction and operations plan, that's ultimately put up for review and approval by BOEM. Everything would be approved by BOEM. The permitting is a variety of agencies at the federal level: Army Corps, Fish and Wildlife, and Coast Guard, and then even Department of Defense. All the applicable federal agencies have to sign off. So here's just a little deeper dive into that review process. It kind of gives you an idea of the steps involved. But you have to undergo 2 sets of environmental reviews. Just to be able to get to the point of establishing the lease area, that requires an environmental review. Just to demonstrate that you're not going to have too adverse impacts to threatened endangered species amongst other environmental issues. And then once the developer creates their design, you'll be going through another environmental review process specific to the final design of that wind farm. So yeah, it's pretty elaborate process, and to easily take up to 8 to 10 years. So that's a big challenge. And you know, one of the biggest challenges is that leasing moment. The bidder, the developer in his bid has to offer a unit price, a kilowatt per hour cost of that the offshore wind farm will deliver. And so that's agreed to in a contract there in the lease. And then that is committed to, you know, years before the wind farm's complete. And now the developer has to take on the cost of steel that has risen, the cost of concrete, the cost of labor. All these issues have to be accounted for and to make sure it's still feasible to deliver power at that unit cost they initially agreed to. So it's quite difficult. And there'll be negotiations later on, you'll see sometimes to adjust that unit price of power. So as you can see, there's all these challenges, planning and the design phase, the approval phase. Staying on schedule is everything. These are high stakes projects. As you can see, the average lease price is over 728 million. The price of power is locked early, and that whole process of planning, engineering, and approvals, it can be, you know, over 8 years, including construction. So a little overview of the offshore wind lease areas. There are a ton. There's up to 65 lease areas across the nation. And as you can see, it's a little tricky to understand here, but to the right here is basically all the East Coast. Yeah, the highest concentration is in the Northeast of these wind farms. What you see up in orange here is off the coast of more Maine, and those will be where the floating wind farms would be. The rest would all be fixed bottom as you go down the East Coast, all the way down to South Carolina. And then you see down here, you know, the kind of the Gulf of Mexico. A few leases have been sold there. Then you see off the coast of California and Oregon, those will all be mostly floating wind farms. You even have leases off the coast of Hawaii that are still being investigated. And so you can see a little close up of the concentration of all the wind farms off, you know, the Northeast, New Jersey, down to Maryland and Virginia. You know, this is really the hotbed of the offshore wind potential. So, you know, with the previous administration, that was the goal, you know, 30,000 megawatts by 2030, 110 megawatts by 2050. As you can see on the right, the East Coast had a very ambitious goal of 50,000 megawatts, 9,000 in New York, kind of leading the way. Keep going here. I know I'm just trying to get through these slides for us. And so the offshore wind lease areas, you know, have been defined off the coast. The leaseholders have to have exclusive rights to try to develop the offshore wind. And the leaseholders have an opportunity to site the cables outside the lease area. So that's the one big variable here is the route of the cables. The lease area is very set, but the cables can be shifted. And the leases are valid for about up to 25 years. Here's your full status. There's more than 322 wind farms operating around the world. The first U.S. Offshore wind lease was Cape Wind. That was in 2009. New York State has really been leading the way. We had our first commercial scale offshore wind project complete. That's South Fork Wind that became operational in November of 2023. We now have Vineyard Wind that achieved first power January of 2024. That's being finished as we speak. But there's so much more potential here. The projected offshore wind generating capacity is over 80,000 megawatts. And here's all the wind farms currently under construction off New York. You've got Empire Wind 1 and Sunrise Wind. Revolution Wind was under construction and the approvals were just halted last week. And then Vineyard Wind is continuing. Continue on here. So there I am in the center. This is kind of a proud moment. So I was there for the ribbon cutting of South Fork Wind. Very exciting for New York State. So, and here are the first operational wind farms. Coastal Virginia was 2020, and Block Island, that's serving Rhode Island, really just Block Island of Rhode Island. That was 2016, the very first. So we've been talking about the BOEM process. The state has a planning and review process as well. And then the developers have to go through their process, fulfilling all the requirements in their contracts. New York State Offshore Wind Program. And Dibs, you tell me when we need to pull the plug here.
Yeah, like you are still on time.
Okay.
No worries, yeah.
Do I have until 6 or what
Yeah,
time?
you can go up to 6 if you want, like again, or if
Okay.
you want, like, to entertain questions before that. Otherwise, like the kids are
Yeah.
going to ask you questions during that
Yeah.
breakout session.
Sure.
This is
Sure.
very interesting. Continue.
Great. Yeah. So offshore wind program was started in 2019 under the Climate Leadership and Community Protection Act. It has a goal of 9 gigawatts by 2035. And you see the goal, 85% reduction in emissions below 1990 levels by 2050, 100% zero emissions by 2040. There's a council that's overseeing this rollout, and they've been very involved in producing guidance for the developers. Here's those goals again, a little more of a breakdown. 9,000 megawatts of offshore wind by 2035. Then you see the solar goal and storage goals, and they're trying to reduce natural gas usage as well. Yeah, so predicting up to 10,000 jobs, enough power for 6 million homes, billions in infrastructure, 30% of New York's electricity load, a third of the state's load. That's a big number. But here's New York in a nutshell. South Fork is complete. The 2 wind farms under construction are diagonal shaded, Sunrise Wind, Empire Wind 1. And you can see these cable routes, vary quite a bit depending on the destination they're delivering power. Sunrise Wind is going to enlarge share power Suffolk County. Empire Wind 1 is going to land their South Brooklyn Marine Terminal, and that's going to be a huge power source for Brooklyn. And that's, those are both scheduled to be complete I'd say early 2027. It might spill into 2028, but right now they're just going like gangbusters under construction. Then you see the other two, Empire Wind 2 and Beacon Wind, still in a planning phase. They need to be renegotiated actually. So here's the power grid. Here's what we're intending to do. Zone K is Long Island. Zone J is New York City. So there'll be at least 2 to 3 wind farms connected to Zone K, but New York City is going to need, a good 3 to 4 wind farms to really power what we need within New York City. But that's the idea. Upstate New York will be a combination of solar, onshore wind, hydro, and nuclear. So yeah, combined economic activity of over 12 billion. There's all your offshore wind projects for New York being proposed. With the currently proposed projects, we'll achieve up to 4,362 megawatts, about half the goal. So we still have a lot more to go on the offshore wind side. Again, a little close-up detail of what projects under construction. Here's where I get involved. I am the offshore wind ports liaison for NYSERDA. So we're trying to do our best to align the ports of New York State to support the construction of offshore wind, but also the operation phase. And so, here you see the various ports that are getting involved. I highly recommend when you get a chance, check out South Brooklyn Marine Terminal. That's Sunset Park in Brooklyn. You could see it from Staten Island Ferry or driving on the BQE. It's heavily under construction right now. I worked a lot on that over the last 2 years. That's going to be a 75-acre site supporting Empire Wind 1. They're going to be staging massive offshore wind components on that port over the next few years. It should be ready by spring of next year. So that's a very exciting one right here in New York City. The rest are kind of distributed across the state. So yeah, as long as we keep this industry alive and maybe changes in the administration in a few years, we're going to have great prospects for jobs and opportunities for all of us as we go forward. And here's the variety of jobs. Stevens Institute, engineering in particular, this is a huge demand for the industry. The planning and design of the turbine components, the wind farm, cable routes, the connections to the grid through the transformers and substations. This is a huge, huge demand right now. Operational engineers, those will be needed once the wind farm comes online, and there's going to be control centers, an O&M control center. One will be at South Brooklyn Marine Terminal, and that will be a control center for the Empire Wind projects. So that'll be many jobs there full time, overseeing the operations and maintenance of those 2 wind farms. There's also going to be a big need for scientists and permitting compliance specialists. That's kind of my world. All the environmental studies needed, the EISs, the permitting, all those approvals needed. Another one is strategic communications. It's very important these days with all the opposition and disinformation on this industry being spread. There needs to be much greater strategic communications to educate the public to understand the benefits of the industry and take away all the mystery of what this industry is. And there's just so much opportunity for US based companies, be it engineering, environmental, contractors, developers, manufacturers, port operators. There's so much opportunity as part of the supply chain of building out these wind farms. But you'll have these slides and you can take a look at all these job opportunities that are out there. And it's not just New York, it's going to be up and down the East Coast, in Massachusetts um, and all the New England states are going to have quite a demand. Connecticut, um, hopefully New Jersey will come back and we'll finally get some wind farms started off New Jersey. There's huge plans there as well. Um, so like I'm saying, it's more than just electrons. There's a lot of research and collaboration to support the responsible development. The goals, especially for New York, is to maximize the cost effectiveness for the consumers, for the ratepayers. We're trying to build out a regional supply chain to support those long-term jobs. It's all connected with this industry. And we're placing a premium on transparent stakeholder engagement and try to get the message out of all the benefits. This is just a quick example of the investments that these wind farms have. So Sunrise Wind here, um, the amount of jobs and investments, it amounts to over 2 billion in near-term enhanced economic development. It's supporting the port investments at the South Brooklyn Marine Terminal and Port of Coimans. But then they also have to, as part of their contract with New York State to deliver power, they have to deliver 32 million in community focused investments to disadvantaged communities. Those are environmental justice communities. 16.5 million towards wildlife and fisheries monitoring, especially during construction, make sure we're not causing deaths of sensitive fish and wildlife species, and then a minimum of 188 million for U.S. purchased iron and steel, per the New York Buy American Act. So there's a lot of collaborative engagement with key stakeholders. New York State has these technical working groups where we focus on, best practices for the environment, for commercial fishermen, for jobs and supply chain, and the maritime side of it too, looking at ports and the maritime operators. So they're really, trying to be very careful and responsible on laying out the construction rollout of this industry across New York State and the international waters, the federal waters where wind farms are built. Yeah, here's their website. You can look up job opportunities that the state is sharing. And this, I'm just wrapping up here with, the current construction happening at South Brooklyn Marine Terminal. I was out there in the spring, but a lot has happened since then. This is a picture from the end of July. This is just one of the piers here. But this is where they're going to be staging, you know, 150-foot turbine towers and other components to load onto barges to bring out to Empire Wind 1 for construction. These crane pads, they have to be constructed to withstand 6,000 PSF So very, very, high strength pads to withstand the weights needed of the cranes and the weight of all the components of the wind turbine. Most ports, rated for like 500 to 1,000 PSF. And these go up to 6,000 PSF.
Yeah, we have a couple more minutes, Josh.
Sure. No, it's great. I'm down about the last slide here. This is the control center. It's almost finished. It's going to be, speaking of sustainability, this one, uh, it's going to be LEED Gold certified. Yeah, they're going to have a green roof, all the recycled water, stormwater. It's just a really cool state-of-the-art facility. I think even the facade captures wind energy. Really, really cool design. And that's going to be there permanently to, operate Empire Wind 1 and 2. So yeah, here's the last slide. So yeah, be on the lookout for these green jobs with developers, contractors, ports, engineering firms, you name it. And it's not just the offshore wind industry, it's the clean energy sector as well. Solar, onshore wind is very similar, some of the components. But there's really just a big push throughout the Northeast, especially, building out these green energy projects. So with that, I'm just wrapping it up here and can open it up to questions.
All right.